everything is in here the right way. And then we're going to go ahead and start. Okay. Alright, so for this first problem right here, it is talking about density. And what we're going to do tonight, we're going to actually go into what's called volume by displacement. And what that means is when you're doing a problem, hence the word volume by displacement, you're going to be given two volume readings. Within those two volume readings, you will have to subtract the two numbers to get your actual volume. So let me just kind of go through and recap for a second what density is. Okay, so this is your typical formula for density. It's D equals mass over volume. Now, when you look at this, okay, and you realize that that is your formula, if you are ever given two volume readings, you're going to have to say V2 minus V1. That's going to give you your actual volume reading or your volume number, all right? So for the first problem right here, it says the mystery metal cube. So we're going to actually go through this problem, and if you all have any questions along the way, just make sure that you all stop me and we can address the concerns. A metal cube is dropped into a graduated cylinder. The water level rises from 50.0 milliliters to 65.5 milliliters. If the cube has a mass of 120 grams, what is the density? All right, so what did they give you in this problem? They gave you two volume readings, the final volume and the initial volume. So that's 65.5 milliliters minus 50.0 milliliters, okay? Well, when you subtract those two numbers, you should get 15.5 milliliters. That is your volume. Also, you were given the mass, which is 120.0 grams. Well, since D equals M over V, my mass is 120.0 grams divided by 15.5 milliliters. What I know is that my answer should be in three significant digits. So if we plug this in, we have 120.0 divided by 15.5, and I get 7.74. Letter B is my answer. Letter B. Okay? All right. We're going to go to the next problem. Number 2. All right, so for number 2, you are given several things in this problem also. So for number 2, it says a gold dental crown is placed in water, raising the level from, so right there, from 22.3 milliliters to 24.8 milliliters. So again, you're just going to subtract 24.8 milliliters minus 22.3 milliliters. And when you do that, let's see what you get right here. You get 2.5 milliliters. So that is your volume. Now, it says that the crown weighs 48.5 grams. What is the density? Again, D equals M over V. So my 48.5 grams divided by my 2.5 milliliters will give us the actual density reading. So if we plug this in to the calculator, we get 19.4 grams per milliliter. So in this case, the answer is letter B. Any questions from anybody so far? All right. So we're going to go ahead and move on then to number 3. So far, based on what we've done, you should be able to solve these problems, with confidence. These problems should not give you a headache, because if you look at what you're given and what's required, then that should be easy to solve. So for this problem right here, it says an object claims to be made of pure silver, which has the density of 10.5 grams per milliliter. If it raises the water in a cylinder from 70.0 milliliters to 75.5 milliliters, and it has a mass of 57.8 grams. Is the object made of pure silver? So what you have to do is say D equals M over V. Oh, you're welcome. Hey, Katie, thank you so much for joining. What you're going to do, you're going to say 57.8 grams divided by, and then the volume that we just calculated. Now, when we get this answer, we're going to compare it to the density that was provided in the problem to see whether or not this is pure silver. So 57.8 grams divided by 5.5 gives us 10.5. And guess what? Is this object made of pure silver? The answer is yes, because the number matches up, the calculated number matches up with the density of silver. All right. We're going to go ahead and keep going. Excuse me. We're going to go ahead and keep going. And again, if you all have questions, again, let me know as we go through each of these problems. Hey, Vish, yes, I do. And they're on my YouTube channel. So if you all want to get the copies of this, you can always go to my YouTube channel. Right there. But ever since now that TikTok has changed their whole thing, you see there are 3 people in this room, right? And TikTok has really screwed up the viewership. So everything is over there on YouTube now. And that's actually where I'm going to start being more. So if you all want to get access, you can just go to YouTube. All right, let's take a look at number 9. So I'm just picking some random problems. Katie, you said you being on TikTok tricks me into studying while I'm scrolling. Well, if that's your reminder, then you make sure you get to it. All right, well, let's take a look at number 9 now. An object has a density of 7.5 grams per milliliter and a volume of 15.0 milliliters. What is its mass? So for density calculations that have you looking for mass, the formula is M equals density times volume. So you all can actually remember this one. And all you have to do now is go in and plug in what you know. 7.5 grams per milliliter times 15.0 milliliters. Cancel out your milliliters and just multiply. So all the other examples that we were doing, we were having to divide, but this time we are multiplying. So 7.5 times 15 gives us 100 and 12.5 grams. Yes, that's right, DJ. This is a free class. I know a lot of students need this, but I'm going to be moving on over to YouTube, so you'll be able to get access to all of these videos by going to my YouTube channel. All right. So tonight's whole goal is just to get you guys comfortable with doing density calculations, knowing what the formula is equal to, then everything else should be fairly simple. Okay, so I'm going to scroll and give you all another example. Let me see here. I'm going to see if you can do this random number 10 problem. Okay. All right, so number 10. Let's see if you all can solve that one. It says a sponge soaked up 84.0 milliliters of water and now weighs 90.0 grams, including the dry sponge. If the dry sponge was 6.0 grams, what is the density of the water absorbed? All right. Now, again, you all know that this is your formula right here. But here's something that they gave you. They told you that the volume was 84.0 milliliters, right? It says that the sponge now weighs 90.0 grams, including the dry sponge, if the dry sponge was 6.0 grams. So you need to figure out what is the actual mass of this whole sponge situation. So there is something else that's going on in this problem, okay? A sponge soaked up 84.0 milliliters of water and now weighs 90.0 grams. If the dry sponge was 6.0 grams, what is the density of the water absorbed? So what you need to find out is the actual mass amount of water that was absorbed. So you would have to actually subtract those two numbers right there. And in this case right here, I get 84.0 grams, and 84.0 grams divided by 84.0 milliliters gives me 1.00 grams per milliliter. So the answer here is letter B. All right. This one was a little tricky, but you have to make sure that you read it and know what they're asking you in the problem. Okay? All right. Okay, good, Katie. That's what you got. Excellent. So now I'm going to give you all some additional practice problems, a few more, okay, before we take off. So I'm going to see if you all can do 1, 2, 3, and 4. All right, so here we go. Number 1. In this particular problem, it says a test tube contains 15.0 milliliters of liquid A, which has a density of 0.85 grams per milliliter, and 10.0 milliliters of liquid B, with a density of 1.25 grams per milliliter. What is the total mass of the combined layers? All right, this problem should not serve as a headache, but what I can tell you is that they're giving you two different things in the problem. And let's go ahead and write down what they told us, okay? So liquid A. Here's liquid A. They told you that your test tube contained 15.0 milliliters for liquid A, and they told you that the density was 0.85 grams per milliliter. Liquid B. For liquid B, it says that you have 10.0 milliliters, and that this one had a density of 1.25 grams per milliliter. But what they want to know is what is the total mass of the combined layers. So what you have to do in a problem like this, you have to calculate the mass of both of them, okay? You're going to calculate the mass of liquid A and the mass of liquid B. And again, to get that, you're just going to multiply the two numbers together, okay? So let me go ahead and scroll down a little bit so you all can see this right here. So the mass of liquid A is equal to 0.85 grams per milliliter times 15.0 milliliters, okay? Get rid of your milliliters, and you've got 0.85 times 15, and I get 12.75 grams, okay? This is the mass of liquid A. Now for liquid B, again, for liquid B, same thing. Density is 1.25 grams per milliliter times 10.0 milliliters, okay? Get rid of your milliliters. Excuse me. And then you're going to multiply 1.25 times 10, and you get 12.5 grams. Again, this is liquid B. Because they say the total mass, all you have to do is add those two together, okay? You're going to add those two together, and then that's going to give you your answer right there, okay? So I'm going to go ahead and add these together in my calculator. Excuse me. And we're going to see what we end up with in this case right here. So 12.5 plus 12.75 gives us 25.25. Hold on, let me double check my numbers. Yeah. Yep. Okay, so right here, this is a typo. And you got 24.75, Katie? look back at your numbers again. Okay, let's go through this one again, okay? So in test tube, a test tube contains 15.0 milliliters and it has a density of 0.85. So in this case right here, you're going to actually multiply these two numbers right here. 15.0 milliliters times the density. That's how you're going to get your mass, by multiplying those two together. And when we multiply those two, we end up with 12.75 grams. Then liquid B, you're going to take 10.0 milliliters and multiply it times the 1.25 grams per milliliter. And that's going to give you your mass of B, which gave us 12.5 grams. And then you're going to add those two together, and you should end up with letter D as your answer, 25.25. Okay, you got it. Good. That one was a little tricky because you had to treat them like they were two separate things, which they are, but you're calculating the total mass for each of them individually and then add them together. Okay. Right here for number 2 now. Number 2. It says a 500.0 gram block of material is dropped into a graduated cylinder. Now guys, I am a visual learner, so I'm going to have to actually draw this out. Now I'm not a drawer or an artist, but I'm just going to demonstrate right here. You drop this 500, which is the mass, gram block of material. The density is 2.50 grams per milliliter. Now, since you are given grams and grams per milliliter, you're solving for your volume. Your volume is equal to your mass divided by your density. So all you have to do here is plug in the 500.0 grams divided by the 2.50 grams per milliliter. And now just go ahead and cancel out your grams because you don't need that anymore. And if we plug this in to our calculator, 500.0 divided by 2.50, it gives us 200, which is letter C. So your volume here is 200 milliliters. Oh, you're welcome. So in this next problem, number 3, it says a pill bottle contains 200 milliliters of medication with a density of 1.12 grams per milliliter. After manufacturing error, 20 milliliters of the contents are replaced with air. What is the new mass? So this particular problem is, you have to read between the lines of what it's asking you to do. So let's just see what was given, okay? We're just going to fill this part out right here. They gave us the density, 1.12 grams per milliliter. They told you that the volume was 200 milliliters, but then after a manufacturing error, there was 20 milliliters of the contents are replaced with air. So we're going to subtract those two, okay? And you get 180 milliliters right there. And what they want to know is, well, what is the new mass of the contents? Well, in order to find your mass, you're going to say M equals density times volume. So 1.12 grams per milliliter times 180 milliliters. Your mLs get canceled out. So if you just go ahead and plug those into your calculator, let's see what you get when you actually solve using the numbers I provided. You should end up with 201.6 grams, which is letter D. Okay, letter D. So, Katie, you got this correct. Very good, very good. Okay, excuse me. Let's take a look at another density type problem. All these examples here are typical examples that you all will see in your average chemistry class, whether it's an introductory to chemistry or your general chemistry 1 class. These are the things that you guys will actually learn, okay? And so you have to learn how to read the problem and not overthink it, because in fact that can happen. And if that does happen, you will get discombobulated, okay? You get discombobulated. And what I have also, I've actually shared this. I actually created a formula guide that would help many of you all. Okay, thank you, Katie. Take care. Thank you so much for joining. But what this formula guide will do is it'll actually help you in terms of knowing what formulas to use for whatever type of problem that you're working with in chemistry. So I actually have the little tip that I use all the time for density, which looks like this. I can give y'all a sample of this so you all will know. If you ever forget how to find the formula for density, okay, you just draw this triangle and put DMV. So whatever letter you cover up, that's your formula that's left over. So in this case right here, D is equal to M over V. If I'm ever having to solve for, let's say, volume, then you can easily figure that out as well. You know that volume is going to be equal to M over D. And then if you're looking for your mass, all right, you cover that up, then M is equal to density times volume. So that's how we were able to solve for all three formulas when given just one, using this triangular system here. Now, let's say that we want to go ahead and solve question number 4. And it says a cosmetic chemist creates a cream using oils with a density of, so this is already what they're giving us. The density is equal to 0.92 grams per milliliter. The final jar weighs 300 grams, including the glass container, which is 145 grams. What is the volume of the cream inside? So in this case right here, they give you two different mass numbers. You actually should subtract those two numbers in order to find out the appropriate mass number, because they said the final jar weighing 300 grams, including the glass container, which is 145 grams. Well, you need to subtract those two numbers. Why? Because you want to get the actual mass of the jar, okay? I'm sorry. You want to get the mass of the cream. So that's 300 minus 145, and we get 155 grams. But now they're asking you to solve for the volume, which is M over D, mass over density. My mass in this case is 155 grams divided by 0.92 grams per milliliter. So again, all you have to do is just cancel out your grams, and you've got 155 divided by 0.92, and I get 168.5. Letter D is the correct answer.